Let's work on part C. Series is n from 1 to infinity 1 by n tangent 1 by n. We are going to use limit comparison test for this one. Again, for limit comparison test also, the series has to be positive, and this is a positive series. Okay. So let's work on it. We need to come up with, this is an, we need to come up with another bn. In this case, I'm deciding 1 by n square. So for limit comparison test, you need to find the limit n approaches to infinity of an divided by bn, which is limit n approaches to infinity. An is this 1 by n tangent 1 by n divided by bn is 1 by n square. 1 n's factor will cancel, and this will be limit n approaches to infinity tangent 1 by n divided by 1 by n. This is equal to 1 from our special limits. Okay. If this limit comes to be 1, then we claim that sigma an and sigma bn either converge or diverge together. Together means whatever, they both act similarly, right? But we know, what about bn? Bn is a p series with p is equal to 2, which is more than 1. Therefore, bn is convergent. If bn is convergent, then therefore an should also converge. Therefore, an also converge. Let's work on part D. Series is 1 by n square root of n square minus 1 and from 2 to infinity. So for this one, let's name the original series sigma an. I'm gonna use limit comparison test, and I'm gonna come up with bn as sigma 1 by n square. We already know that this is p series with p equal to 2, which is more than 1. Therefore, sigma bn converges. This we already know. Okay. Now, limit comparison test, we need to find limit n approaches to infinity an by bn. Limit n approaches to infinity, an is this expression divided by bn is 1 by n square. One factor of n will cancel. So what do we have? Limit n approaches to infinity, n divided by square root of n square minus 1. The highest power of n in the denominator is looking like square, but it's under square root. So that's basically n. So I'm going to divide everywhere by n. When I divide denominator by n, it's going to look like n square because it's under the square root. So what do we have? Limit n approaches to infinity, 1 by square root of 1 minus 1 by n square. We know this thing is approaching to 0. So this limit is coming as 1. Therefore, because limit of an by bn is coming as 1, sigma an and sigma bn converge or diverge together. Basically, they behave similarly, right? But we already know that bn converges, therefore an also converge. So the final answer is the given series converges.